Okay, so we had covered call by value and call by reference in the last lecture. And if you are given any program to find output of this program with function, so sometimes in the printf also you can call the function. In this example, we have called the function inside the printf. So what will be the output of this program if I'm giving a and b as two integers and giving value 2 to a and 3 to b, and I'm calling this function add, that is having the code as in c is equal to a plus b. So copy of 2 and 3 will be sent to this function and then addition will be returned. So its output will be 2, then in next line 3, and in next line 5. Yes. Okay, sometimes what happens, you can call the function inside another function. Like if you are given this example, then it is starting from hash include stdio.h, but there are few functions, there are so many functions uh, whose declaration has been given above main. So in main, you can see hij function has been called. Now control of the program will go to hij. So first it will search for hij, whether it is hij. So this is hij. So now its body will be followed. Yes. So hello will be printed first, but you can see there is another function abc that is being called inside the hij. So now control will not come back to main, but it will now search for abc function. Here you can find abc function, and then this function abc will get executed. So first hello was printed, and in the next line world will get printed. Yes. Now abc has now been finished, so control will now go back to hij, and now hij is finished, so control will now come back to the main program, main function. Yes. Then we have efg. So it will search for efg, it will search for the definition of efg. So here we can see that in efg it is written printf university. So university will get printed in the next line, and control will again, because there is no other statement after this printf, so control will again go back to the main function. So next is the klm. Klm is the now it is this function. So printf thapar. So you can see now thapar will get printed. Now it will again now come back to the main. So this is how you can call a function inside another function, nested function call, you can say. Yes. This is the output. Now the main topic that we're going to do today is recursion, and that is the left this is the only left topic in functions. Yes, this is the last topic in functions. So we are now talking about recursive functions. Yes, recursive function. So once again, I am talking about the repetition. I'm talking about the repetition. Repetition we have already talked in. We have already talked in which topic? We have already talked in loops. Yes, for loop, while loop, do while. But this is another kind of repetition. So we'll see what is this recursion. So these are the functions. So what are recursive functions? Functions that call themselves. Yes, these are the functions that call themselves. It can okay, so let's see this example. So if I say that I have written here hash include stdio.h, and now I have a function void abc. Let us suppose abc is a function. This is the function declaration, and I write here int main, and inside this main I call abc function. Yes. So what happens now, and after that, after this main, I give definition of abc as, now inside the definition abc, this is the function abc, I call this function again. Yes. So how will this program work? So we go to the main function. What is there inside main function? There is a function call, and there can be further return 0. Yes, whatever you have to write, you can write there. Yes. So when control goes to this abc, what is there inside abc? again ABC function call is there. So it is calling itself. This ABC function is calling itself. अपने आप को ये call कर रहा है, right? So it will call itself and it will again go to its definition. It will call itself, again going to its definition. Again call, again call, again call. So it is a kind of repetition. Yes. But अगर ये अपने आप को ही call कर रहा है, कितनी देर तक ये call करता रहेगा? तो अगर हमने loops में we had given some condition कि एक loop जो चलता है, एक नॉर्मल, जब हमने लूप्स के बारे में बात करी थी, सो वी हैड टॉक्ड अबाउट इन द सेकंड पोर्शन, वी हैड टॉक्ड अबाउट द कंडीशन वेयर दिस लूप विल स्टॉप. Yes, this was the condition where this loop will stop. But in this scenario, what we have in the recursive function, see, अगर ये अपने आप को कॉल करे जा रहा है, so what is the scenario where it should stop, where it should stop calling this function? Yes, so that thing is called base condition. We call it as a base condition. So here also we give one condition that is called the base condition, where this function call will stop at some point. Yes, yes, and then we can have some scenario here, and then again control can go back to the main function, because it is the main function only that is getting executed. Yes, okay, so let's go back to this again. So functions that call themselves are called recursive functions, and it can only solve a base case. Base case means it is base condition, we will see. So divide a problem up into what it can do and what it cannot do. What it cannot do resembles the original problem. Let's come to this slide. We can come back to this slide again. First, let us understand what is recursion. When a function calls itself directly or indirectly, yes, when a function calls itself either directly or indirectly, this is called recursive call. So it is the same scenario. So I think I have already told you that sometimes we can also put the function definition above main, then also it will work. Yes, there is no need to give the declaration. So this function is calling itself again and again, but to control this function or to control this program, rather than going into infinite loop in the sense, or loop call, then we have to give some base condition. So C programming or C++ programming language, all these languages supports recursion, that is a function to call itself. But while using recursion, programmers need to be very careful that they have to define an exit condition from the function. Yes, you have to define an exit condition from the function, otherwise it will go into infinite loop. So if it goes into infinite loop, how to control this? That you have to give some exit condition, jahan se ye bahar aayega, and then again it will go back to the main function. So recursive these functions are very useful to solve many mathematical problems. For example, factorial problem, then generating Fibonacci series. So we will see how it is possible. So we are aware of this concept about factorials. Let us suppose I am talking about 5 factorial. So 5 factorial means 5 multiplied by 4 ka factorial. Yes. Or you can say 5 into 4 into 3 into 2 into 1. So this is the actually 5 factorial. But we can make this scenario as 5 factorial means 5 into 4 ka factorial. Yes. And 4 ka factorial kitna hoga? That will be 4 into 3 ka factorial. Yes. So if you have to solve 5 factorial, then you should be first solving 4 ka factorial. Yes. And to solve this 4 factorial, you have to first solve 3 factorial. Only then you will be able to know 4 factorial. Yes. Similarly, if you want to find 3 factorial, then you have to first look for the 2 factorial. और 2 के फैक्टोरियल का क्या है 2 into 1 का फैक्टोरियल. So you have to find out 1 factorial. Yes. So what I am seeing, that 5 factorial is further dependent on 4 factorial. 4 is dependent on 3 factorial. 3 is dependent on 2, and 2 is dependent on 1. Maybe 1 is dependent on 0. So finally, you know that 1 ka factorial is same as 0 ka factorial, that is equal to 1. Yes. So let us make this thing as the base case, right? Let us make this thing as the base case. How? We will see 1 factorial is equal to 0 factorial. So whether you take it, you take both, or either you can take both or 1, so they will solve up to 1. So now you can put this 1 value inside 2 factorial. Yes. So we know that 1 factorial, ऊपर से हमें पता है that it is 1. So now I can put this 1 here and 2 factorial is solved. Yes. When 2 का फैक्टोरियल सॉल्व हो गया है, हमारे पास में 2 फैक्टोरियल की टोटल वैल्यू आ गई है, तो मैं यहाँ से 3 का फैक्टोरियल भी सॉल्व कर लूंगी. नाउ आई एम गोइंग बैक. यस. पहले हम 5 to 1 जा रहे थे, अब हम 1 to ऊपर 5 आ रहे हैं, राइट? 3 का फैक्टोरियल इज 6. नाउ यू कैन सॉल्व 5 ऑल्सो. यस. सो इसको हम कैसे सॉल्व करेंगे? देखो, नॉर्मली आपने फैक्टोरियल का प्रोग्राम किया होगा विद हेल्प ऑफ लूप. What we used to write in that loop, we will see that I am taking fact as 1. This is a variable. Then this can go, this count variable can go from 2 to less than equal to n. Yes. And then you will multiply this fact into count. Yes. So 1 into 2 into 3 into 4 into 5, ये सब आपका एक factorial आ जाएगा if you have to find the factorial of 5. Yes. But inside the recursive function, same program can be done with recursion also. So you can see that what we have written here, factorial int n. So one number will be coming here. If n is equal to 0, then you return 1. Else return n into factorial n minus 1. Yes. N is equal to 0, then you return 1 because this is the base condition. Else you return n into factorial n minus 1. So I'll be taking this condition here, that I have written here in, this was the fact, then I am taking here fact, the name of the function, int n. Then I am taking if n equals to 0, then you return 1, else return n multiply by fact. Same, I am taking again a function called n minus 1. Okay. So what is this? Now you can see here. Okay. So first let us see the scenario. Fact is a function. Yes. 1 minute. So fact is a function, yes, that you are talking about. Now inside this function definition, you can see that again fact is there. Yes. So this is a function call. But इसमें जो ये आप argument देख रहे हैं वो क्या है? n minus 1, right? So if I say that you have fact 5, you have to solve fact 5. 5 is the number that you are giving. So fact 5 को solve करने के लिए आपको क्या चाहिए? You need to solve fact 4. Fine, right? तो ये देखिए क्या है? 5 is equal to 0? No, it is not equal to 0. Yes, else return आएगा मेरे पास में 5 into fact n minus 1. So it will say first you have to, so fact 5 क्या है मेरे पास में? 5 multiply by fact 4. Yes. क्या? तो अब ये क्या है? It is calling itself. ये जो function है अपने आप को call कर रहा है. Yes. जैसे अब now this function will work for fact 4. Okay. फैक्ट 4 के लिए अब ये काम करेगा। पहले क्या था, फैक्ट 5 आया, या वहां पर फैक्ट 5 आया, बट इट नीड्स 5 into फैक्ट 4, सो नाउ इट इज कॉलिंग इटसेल्फ। तो यहाँ अब क्या हो रहा है, फैक्ट 4 जो है, नाउ दिस फंक्शन विल रन फॉर फैक्ट 4। यस, कैसे सॉल्व होगा? सो यू नो दैट फैक्ट 4 के लिए क्या करना होता है हमें, फैक्ट 4 जो है, नाउ इसके लिए हमें क्या चाहिए, this will is 4 is equal to 0? No. So return 4 into fact 4 minus 1. So it will come like this, 4 into fact 4 minus 1 is 3. ठीक है, तो इसका मतलब क्या, अब fact 3 को ये कॉल कर रहा है। Yes, now this function will now work for fact 3. So how will it will be solved? It is now fact 3. It is now 3. So now what it will say? It will say, is 3 is equal to 0? No. Else you have to return 3 into fact 3 minus 1. So it will now work for 3 into fact 2 minus 1 is 2. ठीक है, अब फैक्ट 2 सॉल्व हो रहा है, तो अब क्या होगा हमारे पास में, फैक्ट 2 के लिए दिस फंक्शन विल नाउ रन फॉर फैक्ट 2. So what will happen? I will write here 2. Is 2 is equal to 0? No, you cannot return 1. So you have to return 2 into fact 2 minus 1. So it will come here, 2 into fact minus 1 is 1. Yes, so now it has to work for fact 1. So fact 1 is, this function now will work for fact 1. Yes, yeah. So what happens, is 1 is equal to 0? No, so you can write here 1 into fact 0. Yes, ठीक है, now at this position it will now run for fact 0. ये अब function fact 0 के लिए काम करेगा. So we will see, is 0 is equal to 0? Yes, it is equal to 0. Then you return 1. ठीक है, return 1 में क्या होगा, if you are returning 1 here, if you are returning 1 here, तो क्या होगा, मेरे पास में ये जो फैक्ट 0 है ये सॉल्व हो, क्या आएगा, 1. यस, फैक्ट 1 की वैल्यू हमारे पास में क्या आई, टोटल 1. नाउ ये अब बैक शुरू हो जाएगा. ठीक है, तो ये क्या है, 1 जो सॉल्व हो गया, नाउ ये फैक्ट 1 की वैल्यू यहाँ पर आ जाएगी. सो नाउ फैक्ट 2 सॉल्व हो गया. यस, तो फैक्ट 2 जो सॉल्व हो गया अब उसकी वैल्यू यहाँ पर आ जाएगी, एंड सो ऑन. यस, तो यहाँ पर 6 एंड सो ऑन. फाइन, तो ये ऐसे काम करता है. एक बेस कंडीशन हमें यहाँ पर देनी पड़ेगी, जहां ये सब जो सिनेरियो है सब सॉल्व होकर वापस आ जाए. ठीक है, इस चीज को हम, इस कॉन्सेप्ट को हम स्टैक भी बोलते हैं. स्टैक, यस, स्टैक क्या होता है, जैसे स्टैक इज लाइक यू आर हैविंग अ पाइल ऑफ प्लेट्स. जैसे आप एक किसी फंक्शन में जाते हैं, यू आर गोइंग टू अ डिनर पार्टी, देयर इज अ पाइल ऑफ प्लेट्स. यस, जो सबसे ऊपर एक प्लेट होती है, आप उसको उठाते हैं, तो सबसे नीचे वाली जो प्लेट होती है वो सबसे लास्ट में उठाते हैं. दैट इज द लीफो, इस प्रिंसिपल को लीफो बोलते हैं, लास्ट इन फर्स्ट आउट. तो जो लास्ट में है, लास्ट इन जो गया वो फर्स्ट आउट हो गया. ठीक है, जो लास्ट में जो गया है, लास्ट में जो फैक्ट 1 गया है वो फर्स्ट आउट हो गया, पहले वो सॉल्व हो गया. राइट, दिस इज अ काइंड ऑफ स्टैक. लिनक्स में हम आपको इसको दिखा भी सकते थे कि ये कैसे स्टैक काम करता है. राइट, सो दिस रिकर्सिव फंक्शंस वर्क्स ऑन स्टैक प्रिंसिपल. क्या, तो आप इसको ऐसे, इसको करके देख सकते हो, सॉल्व करके देख सकते हो. इट विल, देन यू कैन रिटर्न द वैल्यू. रिटर्न यहाँ पर एक, जो भी आपके पास में एक रिटर्न, यहाँ एक वैल्यू होगी आफ्टर कैलकुलेटिंग दिस 5, so that will be returned to the main function, and that you can print. Fine, so you can see this example that when you are calling this function n into fact n minus 1, so this value, final value will be returned to the main function, and then you can store it in some another variable and you can print the answer. Yes, there is another example, this has been covered. Yes, there is another example of recursion. 1 minute, let us move further. ये वाला, इस concept पे आते हैं जो हमने ये slide छोड़ी थी. Yes, so recursive functions, these are the functions that call themselves, can solve only they can solve only a base case. Yes, base case हमारा अभी इसमें क्या था, f1 or f0 you could say. Divide a problem into what it can do. What it can do means it can be base case, and what it cannot do means f5 or f4, that could not be solved by that. So what it cannot do resembles the original problem, and the function launches a new copy of itself, recursion step, to solve what it can do. Eventually base case gets solved, जो हमने f0 किया था, that base case was solved, and that gets plugged in, works its way up and solves the whole problem. f5 को इसने solve कर दिया था. Okay, so let's see another example for recursion. So accept the fact that calling 1 minute. Yes, Sonali.
In a recursive function, if the function calls itself way too many times, so would it not decrease the processing speed?
Yes, it can, but sometimes you can it increases the speed also. We will see. Iteration better रहेगा या recursion, we will see later on अभी इसमें, right? So we have another example. I have a function f here that is taking integer x as an argument. Then int y is another variable. So this is the base condition. If x is equal to 0, so then you have to return 1. So here you have taken else y is equal to 2 into fx minus 1. So this is again a recursive function where you are calling this function again, and this x is equal to 0 is the base condition. Otherwise you have to return y plus 1. Yes, so in this example we can see, so when we have to uh, solve the first, if I am putting x is equal to 2, x is equal to 3, then it has to solve first x is equal to 2. Yes, and x is equal to 2, we'll solve first x is equal to 1, and for x is equal to 1 you have to call f0. Yes, so that is the base condition, and then means this is in stack we say that a push operation, this is a push operation, and when you solve the base case then it is called pop operation. So it will pop up the result from the base case, and that particular result will be now popped out for other calls to give the result, final result. Yes. Okay, we have another example using we have to print Fibonacci series using recursion. So I have, can create a function fib n. You can create a logic here, fib n minus 1 plus fib n minus 2. Okay, so what we can do, you know that Fibonacci series gets printed. What is the value? If first two numbers, you can say, you can take 0 and 1, and the next value will be the sum of previous two. So here you can write, if this is at if I am talking about fib n and n is equal to 2, so it will be containing I'm now talking about the location 0 1 2 3. Yes, so if I'm writing 3 is the position, and then it will take 3 minus 1, means it first position and the second position it will take, it will add those numbers and it will put in the third place. So what will be the base case? What will be the base case here? If this n is equal to 0 and or it is n is equal to 1, then it will be returning 1. Yes, it will return this 1. It will return n, you can say, or you can return 1. Both ways you can write. Either you can return 1 here or you can return n. Why? Because n यहाँ पर 0 ही आएगा या फिर n 1 आएगा. Okay, you can return 1 also. Otherwise you have to return Fibonacci n minus 1 plus Fibonacci n minus 2. So Fibonacci is the function that you are taking here. ठीक है, तो इसमें क्या होगा, if you have to solve f3, then first you have to solve f2 and f1, right? Because here we had written Fibonacci n minus 1 and n minus 2, so we have to solve f2 and f1. f1 जब ये f2 जो है, that will require f1 and f0, Yes, and f1 will require f0, or directly you can return 1 or the number itself. Yes, and for f1 1 will be returned, and because this is addition, so you can return n also. इसमें आप डायरेक्टली 1 को भी रिटर्न कर सकते हैं, बिकॉज ऐड करके 0 तो सेम ही वैल्यू रखेगा. ठीक है. तो इसमें इसमें इसका एग्जांपल दिया हुआ है. दिस फिबो नाम का फंक्शन बनाया है, and we are taking this num and result variables. Then I'm saying enter the nth number in Fibonacci series, and then I'm checking whether the number entered by the user is less than 0. So we are saying that Fibonacci of negative number is not possible. And then if it is positive, then I'm calling this function fibonum. Yes. And then I'm taking the result from fibonum and I'm printing the result. Yes. Now when fibonum, the fibo function is called, we are going, control will go to this function definition, and we are giving the base case as if num is equal to 0, then you return 0. Else if that number is equal to 1, then also you return 1. It is same. We are, जो लास्ट में हमने लास्ट एग्जांपल करी है ऊपर, यहाँ हमने क्या किया था, 0 और n इज इक्वल टू 1. तो ये जो दो हमने यहाँ दो कंडीशंस को इकट्ठा किया, हमने यहाँ इस एग्जांपल में अलग अलग करके लिख दिया उसको. ठीक है. एल्स क्या है, एल्स यू आर रिटर्निंग फिबो नम माइनस 1 प्लस फिबो नम माइनस 2. ठीक है. तो इसको सॉल्व, दिस इज सेम, इसको आप सॉल्व करके देख सकते हैं. So there is a difference between recursion and iteration. Iteration is explicit loop and recursion is repeated function call. Mainly you are, when you are talking about recursion, then you will be talk about functions only. Termination of loop. Iteration fails when a condition is false. Yes, but recursion में हम एक base case देते हैं. When that base case gets solved, then only you can solve the whole recursive function. Both can have infinite loops. If you are not giving any base condition in recursion, or you are not giving any condition in the iteration, then both can go in infinite loops. But it choice is yours, that choice between performance. If you have to talk about performance, then you will be going with iteration, as Sonali had just asked. Yes, and it is good software engineering. But recursion is a good method where you can, function can call itself. But every time in big problems you cannot put iteration at each step. Yes. So recursive function is easy to understand, you can say, right? What is tail recursion? So a function that calls itself, that is recursion, and does not perform any task after function call is known as tail recursion. You generally call the statement function with return statement. अगर आप last में ऐसा ऐसा कुछ डाल देते हैं, that is called tail recursion. मतलब इसके बाद में आपके पास में और कोई statement नहीं है. That means the, if you are talking about factorial 5, then you will be directly jumping to the return statement. 5 into factorial 4. Again, factorial 4, you are jumping into only this one statement, that is return statement. Yes. Okay, so here we end with the function topic and this topic. If you have any questions till now, you can ask me, then we have to start with other. If you have any questions, please ask me. Please raise your hand. So you might have got messages through your GR that we are holding sessionals for this subject from 21st. It will be probably from 21st December to 25th December. Yes, and its syllabus will be up to functions, but after functions we have storage classes also. So storage classes will be included in the sessional syllabus. That sessional will be for 15 marks. I will be writing it here again. So your sessionals will be, tentative date is from 21st December to 25th December, in between, right? Any in between any day we can take, and it will be for 15 marks. Yes. So 10 marks का इसमें होगा, MCQs होंगे उसमें. MCQ is multiple choice questions. Yes. And there will be a program also. ठीक है. That will be maybe of 15 marks of course. प्रोग्राम को आपको सॉल्व करना है, उसको पूरा compile and execute करना होगा. And this will be done on ebox. Ebox, I have been talking about ebox. That is a tool. ebox पे आपके accounts बन जाएंगे. So उसमें आपको ये परफॉर्म करना होगा. आपको लैब में इसके बारे में ज्यादा बता देंगे. Otherwise I'll be once I'll talk about this tool. It is not a tool actually. We'll talk about ebox in the class also. ठीक है. पहले एक बार आपके अकाउंट बन जाए, then you can know better. तो उसमें आपका अपना पर्सनल लॉगिन बनेगा. आप अपना उसमें एग्जाम दे सकते हैं. प्रैक्टिस क्वेश्चंस हैं वहां पर आपके पास में, प्रोग्राम्स हैं दैट यू हैव टू क्रिएट. यस. ठीक है. एंड इट्स सेशनल का सिलेबस ये इसके लिए रहेगा आपका अप टू स्टोरेज क्लास, अप टू स्टोरेज क्लासेस. ठीक है. फंक्शंस के बाद में टॉपिक आता है. सो फर्स्ट 3 पैराग्राफ्स ऑफ योर सिलेबस विल बी कवर्ड. यस. So that will be your syllabus for sessional. Any question? अभी तक के लिए कोई question है तो बताइए. Any question, any doubt till this these functions, recursive function, or any doubt in this scenario जो मैंने अभी आपको बोला sessionals का? Any doubt? Please ask. Raise your hand if you have any doubt. Then shall we start with next topic? Any doubt if you have, please ask. ठीक है. Then I will start with next topic. So in the next topic we have storage classes. We have storage classes. Yes. So storage class specifiers that we are talking about, they tell us what is the duration of your variable, how long it gets stored in the memory. Yes. How long an object exists in the memory, and scope where object can be referenced in the program. So we will be talking about auto external register and static. Yes. So storage classes हमें क्या बताती हैं कि हम जो एक वेरिएबल फॉर्म करते हैं, लाइक इफ आई राइट int a, int b, तो ये कहाँ पर जाकर स्टोर होते हैं. एंड वी विल बी टॉकिंग अबाउट this auto external register static. So if I am talking about storage class, like I'm writing int a. Yes. So if I am defining this in main, of course I'll write here in this compiler, I'll write here int main, और सब अपना hash include ये सब अपने आप से डालोगे. Yes. तो अगर मैं यहाँ पर int a लिख रही हूँ और int b लिख रही हूँ, तो ये कहाँ पर जाकर स्टोर होगा. Yes. क्या इस कहाँ मेमोरी में कहाँ पर जाकर स्टोर होगा, and how long I can use this in this program inside this main function, like in these parentheses, ये यहाँ से शुरू हुई और यहाँ पर खत्म. ठीक है. और साथ में क्या इसका स्कोप है. यस. इसका स्कोप यही कि इसका लाइफ टाइम क्या है. व्हाट आई विल बी डूइंग, so we will be talking about, just now we have learned, we will be talking about automatic, then register, then static storage class, और कौन सी थी, external. Yes. Global जिसको हम बोलते हैं. Yes. So that is called external. ठीक है. तो इस वेरिएबल के आगे मैं यहाँ पर ऑटो now you can see, can you see, जैसे ही मैंने ऑटो लिखा वो भी अभी क्या है, बोल्ड में आ गया है. It means it is a keyword. Can you see that int is a keyword? Yes. Do you remember what are keywords? They are reserved words. Yes. So auto is a, तो अपने आप ये क्या है, it is a reserved word, it is a keyword. Yes. तो auto int मतलब मैंने एक int के आगे auto लिख दिया है. आई एम नॉट टॉकिंग अबाउट लॉन्ग इंट, अब साइंड और अनसाइंड इंट, ठीक है। जो साइंड और ये सब ये थे लॉन्ग थे, वो डेटा टाइप्स में आता था। बट ये जो चीजें हैं ऑटोमेटिक, रजिस्टर, स्टैटिक, एक्सटर्नल, ये सब हमारे पास में स्टोरेज क्लासेस में आती हैं कि ये इंट ए कहाँ पर स्टोर होगा, कैसे इसका स्कोप रहेगा, कैसे इसका लाइफ टाइम रहेगा, ठीक है। तो ऑटोमेटिक के लिए हम ऑटो लिखते हैं, रजिस्टर के लिए रजिस्टर लिखते हैं। नाउ यू कैन सी अगेन इट इज इन बोल्ड, ठीक है। स्टैटिक के लिए स्मॉल में मैं स्टैटिक लिखूंगी, एंड एक्सटर्नल के लिए आप एक्सटर्न लिखते हैं, ठीक है। ओके, सो दीज आर द कीवर्ड्स दैट आई कैन पुट बिफोर इंट। यस, सो ऑटो डाल सकती हूँ, इसके आगे रजिस्टर डाल सकती हूँ, स्टैटिक डाल सकती हूँ, और एक्सटर्न भी डाल सकती हूँ, ठीक है। ये हम कैर को किसी करेक्टर के आगे, फ्लोट, किसी भी डेटा टाइप के आगे इसमें डाल सकते हैं। Let's now come back to this. So storage class specifiers, they tell about the storage duration, that how long an object exists, or the variable. Here you can say that a variable exists in the memory. And scope, that where object can be referenced in the program. कहाँ पर हम एक वेरिएबल को यूज कर सकते हैं, मेन में यूज करेंगे या कोई फंक्शन बनाया है उसमें यूज कर सकते हैं, कहाँ पर यूज कर सकते हैं, ठीक है। सो दैट विल बी सीन. So program scope, what is the program scope? So identifier defined outside the function, known in all the functions, and it is used for global variables, function definitions and function prototypes. तो अगर मैं आपको एक ये कहूँ कि मैंने एक प्रोग्राम बनाया है, ये मेन कहाँ है, ये प्रोग्राम है, तो इसका स्कोप कहाँ तक है, तो एक प्रोग्राम का स्कोप, तो ऑफ कोर्स ये प्रोग्राम पूरा है। इफ वी टॉक अबाउट दिस प्रोग्राम, ये कहाँ तक चलेगा, सो इट मीन्स that I'm talking about the global variables or the function definition also for that program. Yes, but if I am saying that function ka scope kya hai, it can be only reference inside the function body. If I am talking about this function, इस function का scope क्या है, इस फंक्शन का स्कोप तभी है जब आप इसको कॉल कर रहे हैं मेन के अंदर। अगर मैं इसको कॉल भी नहीं कर रही हूँ तो चाहे ये फंक्शन यहाँ पर इसको कोड को रखे रहने दो, ओनली then also it will not get executed, right? Okay, so now I'll be taking your questions, but this is a long topic, तो इसको मैं पूरा examples के साथ में इसको समझाऊंगी. It will take more time, but now we are left only with 5 minutes. So if you have any questions, please ask me. अगर ये चीज नहीं भी समझ में आई, then we can anyways we have to discuss in next lecture. If you have any questions, please ask me. Any questions regarding this course, or any or regarding sessionals, anything else? I hope your labs are going good and you are coming in labs, you are punctual in lab, and you are able to perform also. Any questions?